More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at Home, real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at Home is right for your child, visit mathnasium.com/at-home. Mathnasium at Home, changing lives through math.
Hello everyone, welcome to Mathnasium Schoolhouse. Today we are going to be doing our second lesson on problem solving with fractions. So we'll go ahead and give everyone just a few more seconds to join. Make sure that you have our follow along worksheet downloaded so that way you can do the problems along with me today. And we will go ahead and get this all set up and going. So today's going to be very similar to yesterday. We're just going to be doing some word problems and different types of things with fractions. So let's go ahead and get started with a little bit of a warm-up question. We want to know how much is half of 15? How much is half of 15? Well, yesterday we did a lot of practice with drawing pictures when we're working on these problems. So, if I know that my whole is 15, and the question is asking for half of half, and it looks like we have some people looking for the worksheet. It's in the title or in the description of the video. There should be a link at the very end that you can click and download the worksheet. And I'll let you guys know when I switch pages, so that way, if I get a little bit ahead of you right now, you can catch up to where exactly we are. And then you can finish those problems later. You can go back and watch the video and catch up. So, if our whole, back to number 1, is 15, if we look at half of that, what is half of 15? Does anybody want to tell me what half of 15 is? Very good. Half of 15 is 7.5. So now I need another half, because half of a half, we could also call that a quarter. So what is half of 7.5? We're dividing our 7.5 in half. What do we get to? Close. Couple close answers. The answer we're looking for half of 15 is 3 1/4. I'm sorry, 3 3/4. Get my brain working too. 3 3/4. Very good job. Okay. Next one here. A sandbox is half full of sand. 200 pounds of sand are added, and now there's 750 pounds. So how much sand can the sandbox hold all together? So if we have our sandbox here, and it's currently half full, and we don't know how much sand that is. We're not sure how much that sand weighs, but we know that 200 pounds are added, and we don't know what fractional part that is, so we'll just draw ourselves a line there. And we've got 200 more pounds, and we now know that all of the sand in our sandbox is 750 pounds. So, can we figure out how much sand it was when it was half full? Well, if I have 750 altogether and I added 200 to my half, I know that half of my sand must have been 550. So altogether, my two halves must be the same. They must add up to, very good, 1,100 pounds. We know that our halves are 2 part the same, so they're both 550. Add those up, we get 1,100. Nice job. Okay. Number 3, and we're still on page 1 for those of you that might just be getting the worksheet. We're on problem number 3 of page 1. How much is 2/3 of 3/4? 2/3 of 3/4. So we have a picture drawn here for us already. And we have 3 pieces shaded in. So that's our 3/4. And we're really only looking at that 3/4 right now. So I'm going to cover up this extra fourth with red. So let's just pretend that that's not there for right now. I want 2 of these 3 pieces. So we'll do that in blue. So I'm going to count 1, 2 of these 3 pieces. But it's asking how much that is out of our original picture. So we need to look at the whole fraction again. So 2/3 of 3/4, when we're looking at the whole, is 1/2. Very good. So now 2/3 of what number is 1 whole? Well, if these 2 shaded in parts here, both of my shaded in pieces add up to 1 whole, what does each part have to be? Each of these pieces has to be a half. And we know that this fraction is divided up into thirds, which means all of the pieces need to be half. So what does our whole fraction represent? Because this is asking us 2/3 of some number equals 1. So 2/3 of the value of our whole is 1.5. Nice job. Very good. Okay. So now we're looking at number 5. Last problem on page number 1. You have a box of cookies and you eat half of them after lunch. You eat half of what you have left after dinner, and now you have 4 cookies left. So what did you have to start with? So I'm going to draw my box of cookies up here above number 5. And I ate half of them after dinner, so that half is gone. And then I ate half of that as well, and I have 4 cookies left. So what fraction of the whole do we think that 4 represents? It's half of a half, and we talked about that earlier, is a quarter. So my whole box needs to be divided up into fourths. And if each fourth is 4, I had, very good, 16 cookies to begin with. All right. We are on to page number 2. So if you're following along here with me, we're now on page number 2. So can we explain why 1/2 plus 1/4 equals 3/4? Well, let's do it maybe with a picture first. Do it a couple different ways. Why 1/2 plus 1/4, there's my half, and there's my fourth, equals 3/4. So that's one way we could explain it, right? We could use a picture, or we can use common denominators. And another way of writing 1/2, if I want my denominator to be 4, is the same thing as 2/4. And I know that 2/4 plus 1/4 equals 3/4. Okay. Number 2, on page number 2. How much is 3/4 divided by 1/2? How much is 3/4 divided by 1/2? When we think about division, we can think of it as how many of these are in that. So if I asked you what 10 divided by 2 is, what I'm really asking you is how many 2's are in 10. So if we look back at our original problem, what we're asking is how many 1/2's are in 3/4. If I look at my shaded picture here, I have 1/2, and then I see that I have a half of a half left. So how many halves are in 3/4? Very good. I have 1.5 halves in 3/4. Good job. Number 3. How many 1.5-inch blocks are needed to make a stack that is 1 foot high? Same kind of question. We're asking how many 1.5s are there in 1 foot. Well, first we need to know how many inches are in 1 foot. That's 12 inches. So how many 1.5s are in 12 inches? What do we think? A couple different ways to do this. We can count by 1.5 until we get to 12. Well, I know that gets me to 3. So 2 1.5s get me to 3. And I know that there are 4 3s in 12, which means there's how many 1.5s? If there's 2 per 3, give myself a little more room here. 8. Very good. We need 8 blocks. Nicely done. Nicely done. Okay. Number 3 on page 2. Oh, and we did that one already. Cross that off. We're on number 4. A quarter of a pound of candy costs $1.50. How much does a whole pound cost? Give ourselves a little picture here. So 1/4, 1/4 costs $1.50. So how much does the whole pound cost? Yeah, nice job. $6. Very good. Number 5. After running 2/3 of a race, a runner has 4 miles left to go. How long was the race? So we've got our race here. We'll just say they're running in a straight line. Makes life easy. So there's our racetrack. Pretend we're looking from up above. So if they ran 2/3 of the race already, there's my thirds. So they ran 1/3, they ran 2/3, and they had 4 miles to go. How long is the whole race? Well, if 1/3 is 4 miles, 2/3 would be 8 miles, and 3/3, or the whole, very good, is 12 miles. Nice job. Okay, we are on to page number 3. So for our worksheet, we're on page number 3. A little bit of a longer problem here. So let's go ahead and get started. 3 people buy a thing. They buy something. Let's say they bought a TV. Let's say they bought a TV for $200. The first person contributed $40 for the purchase. The second person put in $100, and the third person put in $60. Okay, so we have 40 out of the $200 contributed by the first person. We have 100 of the $200 contributed by the second person. And we have 60 of the $200 contributed by the third person. And now they go and they turn around and they sell their TV for $240. So they made a profit. So how should they divide that money equally so that it's fair? Well, we need to look back and see fractionally how much each person contributed to the original purchase of the TV. So I have the original amounts here, and we can reduce these numbers down. So I'm actually going to give us a little bit more room to work with here. Okay, so 40 out of 200 is how much fractionally? Well, I can reduce them both by a factor of 10 right off the bat and make it 4/20. And I can reduce that even further. Both of these numbers are divisible by 4. and that gets me to 1/5. So our first person, and we'll keep track of these up above, our first person put in 1/5 of the amount. Our second person put up 100 out of the $200. And that one's pretty easy. We know right away that that's a half. They put in half. So that's how much they should get back. And our last person here contributed the final $40. Or I'm sorry, the final $60, which we can reduce to 6/20ths, which I can reduce to 3/10ths. Okay? So, looking at all of this now, I have, in the lowest terms, how much each person contributed fractionally to the total amount of the purchase of the TV. So now I need to figure out, based on their profit, how they should divide it. How should they divide their profit? So it might be easiest to think about this if we get all these fractions to have a common denominator. So what is the least common multiple between 5, 10, and 10? How can we rewrite these fractions so that they all have the same denominator? We can use tenths, very good. So I can change my 1/5 to be 2/10 and my 1/2 to be 5/10, and then I have 3/10. And looking at the profit, altogether, all of my tenths add up to $240. So how much is 1/10 of $240? And that'll help us figure out the rest. If my whole is 240, that means 1/10, and we'll write that over here, 1/10 is $24. So our first person got 2/10, 2 24s is $48. My second person gets 5/10, and 24 5 times is $120. And my last person gets 3/10. The remainder of the money is $72. A little bit of a longer problem, but I think that one's pretty fun, a pretty cool way to use some of the different skills that we've been working on. So number 2 on page 3, talking about candy. 5/6 of a pound of candy costs 60 cents. So what is the cost of a half a pound of candy? So we have 5/6 of a pound of candy. 5/6 of a pound costs 60 cents. So what is 1/6? How much is 1/6 cost? What's 60 divided by 5? Yeah, very good. 1/6 is 12 cents. And how many 1/6 make up a half? Well, I know that 3/6 is the same thing as 1/2. So 12, 3 times, is 36 cents. Nice job. Very nicely done, everyone. All right. Problem number 3 on page 3. How can you share 2 candy bars between 3 people? I've got my 2 candy bars here. How can I share them between 3 people? I split each candy bar up into 3 parts, and I give each person 2 of them, they each get an equal amount. Very good. 2/3. Nice job. Very nice. All right, so looking at number 4. Who has a better free throw percentage? Freddie or Jamie? So Freddie made 17 out of 24, and Jamie made 8 out of 12. And we know that it's easier to compare fractions when they have a common denominator. So I'm going to go ahead and make Jamie's fraction look like Freddie's. It'll be a little bit easier to look at. So if I multiply both of those numbers by 2, I now have a common denominator of 24 for both of them. So now looking at our free throws, who had a better free throw percentage? Freddie or Jamie? Jamie did. He made 1 more. Out of 24 shots, he would have made 1 more. So his percentage was better. All right. Number 3, how many half inches are in 1 mile? Can somebody tell me how many feet are in 1 mile? That's where we need to get started. If somebody can tell me how many inches are in 1 mile right off the bat, I'll be very impressed. But we'll start with feet. How many feet are in 1 mile? Yeah. 5,280 feet. So now we know how many feet are in 1 mile. So we now are asking how many half inches are there in 5,280 feet? So let's think about how many inches are in 5,280 feet. Might be easier to compare half inches or count half inches if we know how many inches there are. So 5,280 feet. Well, we know there's 12 inches in 1 mile. Or I'm sorry, 12 inches in 1 foot. There's 12 inches in 1 foot. Yeah, very good. So that means that there are 63,360 inches. So how many half inches are there in 63,360 inches? How many half inches are there? Well, half is 2 parts the same, so I need to double my amount of inches. If I'm counting half inches, I'll have twice as many, which means there will be 126,720 half inches in a mile. Very good. All right. On to page number 4. So we're doing number 1 on page number 4. So it tells us right off the bat, we have some information provided to us that a furlong is 1/8 of a mile. So if a furlong is 1/8 of a mile, how many furlongs are in 1 mile? Yep, 8. 8 furlongs. So then how many furlongs are there in 1¼ miles? Well, I know that in 1 there's 8, so that gives me a good starting point. So then I'm really looking at how many 1/8 are in 1/4. How many 1/8 are in 1/4? Good. 2/8 are the same thing as 1/4, which means I have 2 more from part A, which gets us to 10. Nice job. All right, so then how many furlongs are there in 1 1/16 of a mile? So again, we know in 1 whole mile that there's 8, so that gives us a good starting point. How many 1/16 are there in 1/8? Yeah, very good. There's half of a 16th. So 8 gives me my whole mile, and a half a furlong gets us our 16th. Good job. So what part of a mile is 6 furlongs? What part of a mile is 6 furlongs? Well, I know that 8 furlongs is a whole mile. So 6 furlongs must be 6/8 of a mile, but we can reduce that fraction. Both of these numbers are divisible by 2, and that gets me to 3/4. So 6 furlongs is 3/4 of a mile. So now what part of a mile is 7.5 furlongs? So we'll set this up the same way we did for the last one. 7.5 furlongs over 8 furlongs we know as a whole. We can't leave the answer like this. This is not an appropriate way to write this answer. So in order to get our numerator to be a whole number, what can we do? If we multiply both numbers by 2, I get 7.5 doubled is 15/16. Very nice. Very nicely done. Okay. Question number 2 on page number 4. A game of basketball consists of 4 quarters of play. It's asking us to draw a diagram. Game of basketball consists of 4 quarters of play. Halfway through the second quarter, how much of the game is left? We're going to use a different drawing, actually. All right, 4 quarters. So we're going to divide our whole game up into quarters. And we're talking about halfway through the second quarter. So our first quarter is done. First quarter is done. And we're halfway through the second quarter. So what fraction does it look like we have now? Half of a quarter is an eighth. So how many eighths does it look like I have left here? 5. Nice job. 5/8 of the game is remaining. Nice job. Okay. Number 1 on page number 5. If a third of a job can be done in 20 minutes, how much longer will it take to finish the entire job? Asking us to draw a diagram again. If a third of a job... Ooh. Terrible drawing. Try that again. All right. That's a little bit better. If a third of a job can be done in 20 minutes, how much longer will it take to finish the entire job? So we've divided our whole job up into 3 equal parts, and we know that one of them is 20, which means the rest of them must be 20 as well. But it's only asking about the job, the part of the job that's left. We've already done our first part, so we're really only looking at this remaining 2/3 of the job will take us 20 and 20, gives me 40 minutes. So a couple people said 60 minutes, which is the length of the entire job, but it's only asking us how much longer will it take to finish the job. So it will take us the other 2/3 of the time, or 40 minutes, to finish our job. All right, number 2 on our last page here, page number 5. 3 people share a pie. The first person gets half. Can the other 2 people get 1/3 each? Explain why or why not. 3 people are sharing a pie. The first person takes half of the pie. can each person get a third each? So a third each would mean 2/3. Is there 2/3 of this pie remaining? There is not. Another way to look at this is we could say if the first person ate a half and each person thereafter wanted a third, that's how much pie that we would need, and we only have one. We have one pie. And if I want to look at these fractions, if I want to add them up, the only way we can do that is with common denominator. Our common denominator here is going to be 6. So I've got 3/6 plus 2/6 plus 2/6, and that's 7/6. That is more than 1. So the amount that they want is more than they have, so they cannot. So how could the other two people share the rest of the pie equally? Again, if we look at our pie here and we had one person eat half of it, how could the last people share equally this last part? We could split our other half in half, and that gives us, they could have 1/4 of the pie each. Nice job. All right, last one here. Number 3 on page 5. Thinking outside the box a little bit. 1/2 of a third of a fourth equals what? 1/2 of a third of a fourth. 1/2 of a third of a fourth. How do we go about this? What do we think? I'm try and draw a really big picture here to make these pieces small enough. Oh, not big enough at all. Let's see here. Big circle. Okay, so we're going to start with our fourth. So we have our fourth there. And we want a third. So we're going to divide our fourth into 3 parts. So we have our third of a fourth. We took care of this part, a third of a fourth. And now we want to take that piece and divide that in half. Very small. So if I did that to the rest of my pieces here, how many do I have? Well, I've got 1, 2, 3, 4, 5, 6 in just my top quarter. So my quarter is now divided into 6. So if each quarter is divided into 6 pieces, 6, 6, 6, 6, that gives me the total number of parts in my whole is 24, and I just want one of them, one little sliver. Very good job, is 1/24. Nice, and I see some great explanations in there. So that is all we have for today. I really appreciate you guys tuning in and listening. I hope you enjoyed the last 2 lessons on fractions. We're very glad to have you guys here, and we're excited to see you tomorrow and during the rest of the week. If you enjoyed today's lesson, we'd really appreciate if you would share it out with your friends so they can see it as well. And we'll see you guys tomorrow.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do 1/2 of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.